Hello everybody, my name is Alfonso Landverde. I am here to get us started with Lab 1 charge tapes for Physics 2212. And to get started, we have the intro here, which explains kind of the purpose and some of the principles used for the lab. So the purpose of the lab is to observe the transfer of electrons between surfaces and find the number of electrons transferred, for example, and we get to do so using tape as our model. So models and principles. So tape serves as a model for point charges. It's kind of a gross oversimplification of it, but it works. And then some principles that we use are Coulomb's law and Newton's second law. So Coulomb's law equals, or is force is equal to K over, or K times the charge of the first particle times the charge of the second particle, and then divided by the distance between the two squared. And then Newton's second law would be force equals mass times acceleration. And we'll get into how these equations are used in our observations quite shortly. So let's start from the back with as far as this lab goes. So the tapes ended up both being positive, and the glow script code provides calculations for the rest of the results. So I will look at those right now for us. So here we have our glow script code, and when we run it, we get this. I'll explain the code, of course, in a moment, like when we get to that section, but the rest of the results are that we found that the charge of the piece of tape is 1.32 times 10 to the negative 8th coulombs, and we found that the deficiency of electrons on a piece of tape is 8.278 times 10 to the 10th, and then there are 4.59 times 10 to the 6th atoms for every electron on one piece of tape. And we get into how we were able to find that using this code in a moment. But conditions, ooh, I didn't oopsies and used my scroll wheel. Apologies for that. Okay, conditions. So the system for this experiment is we have tape A and tape B, which are just two pieces of tape. The surroundings is everything else, that's not the tape. And then we assume both tapes are equal in neutral charge, length, and width. So our experiment, we take A and B, and we put them together and we let them chill for a bit. And then we have a third piece of tape that's placed on the desk. And then we stick tape B to the desk tape and then rip it off, which should change the charge because just it does. And then we test it to find a new charge. And we test it with a whole bunch of items and to kind of see, okay, this item is positively charged. If this goes here, we see how it interacts, and then we should be able to come to a conclusion on what the charge would be. So then after that, when tape B is placed near tape A to see if it floats, it does do so, congrats. And then the distance is measured to find the charge. So our observations would be these. These are my notes for them. So the piece of tape attracts to my hand, um, and then both pieces of tape have the same charge, so it repels. It attracts to a whiteboard, which is of neutral charge. The pen is negative and it attracts, and that basically gives us that it's positive. And then when we try it with the tape floats, meaning they're both of equal charge. If they float, then they're repelling, so that means that both the pieces of tape are positive. Okay, now on to slide 6. Possible errors are assumptions being proven wrong and human error. So at the earlier on in this, I'll go to the slide just to show you. We oversimplify our system. We say that both tapes are equal in length, width, charge, not mentioned there, but mass. We say both the tapes are entirely equal, and then on top of that, we then simplify pieces of tape and we turn them into point charges, which would be kind of like particles, which they aren't. So differences between what our glow script code produces and what actually occurs in the real world would be because our glow script treats them like tiny particles in, a tiny system, when it's really two pieces of tape in a big system. Then other things could be human error. I'm prone to make mistakes. I mean, I already made one in this PowerPoint, but you get it. And then what ifs and whys. So what if the electrons had positive charge and protons had negative charge? What changes about the observations would you make with your tapes and other charged objects? So if I'm reading this question right, I assume there'd be no changes because the electrons are positive and now the protons are negative. So they just switched. So I think all the interactions with the objects would remain exactly the same. And then why is it important to handle charged tapes as little as possible? What happens when the charged tape comes into contact with your hands or other objects? When we change the charge by quickly ripping the tape off of the other tape, um, we undo it basically by handling it with our hands or other objects, because then the electrons and other particles interact with each other and they return it back to normal because it's just how it works. They attract to each other, they try and become balanced. And so we don't want to remove our little temporary charge that we've created on it, at least for showing our experiment. And then conclusions slash thank you for listening. Apologies for um, I don't know, being me with this stuff. But conclusion. So one can charge objects like tape and use the formulas from before to find the charge of these objects. So we can use Coulomb's law and we can use other things to oh, by this point I should have shown you the code. Oh, oops. So let's see some differences in our code actually before we get to the conclusion. So here are our constants. We measure out the charge of it, or we know the charge of an electron. We know the charge for K. We know or we know the value of K, 9 times 10 to the ninth. Then we measure the distance, we know gravity, and we measure the length and width of our tape. And then we know the atom length, and this is just me setting the scale for the experiment. And then some calculations. So we have to find the force of gravity, which is just mass times gravity. And then we need the electric force, which would just be the absolute value of that. And then we get the value Q, which is the charge of one piece of tape, and that would be the electric force divided by K over R squared, or magnitude R squared. And then that gives us our charge for tape. And then if we want the efficiency of our electrons like we found, it would just be the electron count is Q divided by Q electron. And then if we want the electrons to atoms, we just divide the atoms by the electrons. And that's how we got our glow script code to run. My bad for not explaining that before getting to the conclusion, but let's get back to it. So objects can be charged like tape, and and use the formulas in our glow script and in the principles slide of this presentation to find the charge of the objects. And then objects like tape can model point charges in physics equations. Anything can probably serve as a point charge if you decide to grossly oversimplify a system. But for this one, we use tape, which allows us to estimate, how those micro interactions are working, which is cool to do. Okay, that's all. Thank you.